Welcome to day 2 of 5.1 Trig Identities. Today we're going to get a little bit more in depth with simplifying fractions, expressions with trig, and really using those identities. So on each slide that I have today, I have put like a picture of some of the Pythagorean identities, and on other slides I have a bunch of the identities. So they'll be easy for us to reference today, but I highly recommend that you just have them written out or like in your notebook when you took notes yesterday on the identities. Just have them so you can see them and reference them. The more you see them, the better you'll be. All right, let's do a quick review of difference of squares. This is something that comes up a lot with the Pythagorean identities. I'm going to do one that's non-trig based to start, right? So if we have like x squared minus 9, that's a difference of squares because this is a perfect square, 9's a perfect square, that's a difference. So we can rewrite this as x plus 3, x minus 3. Why can we do that? Well, if we were to FOIL this out, right? And I hate the word FOIL, let's just distribute. So we'll distribute the x through, then we'll distribute the 3 through. You know, look what happened. Those cancel and we're just left with our difference of two squares. So essentially, the way that we want to write a difference of squares in general is if you have, a squared minus b squared, we can write it as a plus b, the square root of each, and then a minus b. So how does that relate to trig? Well, you can see that we have a lot of squared terms in here. And when we rearrange them, we'll have differences. So let's explore that next. All right, we can rewrite this top one, sine squared plus cosine squared equals 1. If we subtracted cosine squared from both sides, wouldn't we have this? Sine squared of theta equals 1 minus cosine squared. So all I did was just rewrite this top one. This is the same Pythagorean identity as over here. But in this case, we rearranged it so we now have a difference of squares on the right-hand side. That can be simplified. This is a difference of squares. 1's a perfect square. Its square root is 1. Cosine squared is a perfect square. Its square root is cosine. So when we rewrite this, we can rewrite it as 1 plus cosine of theta, 1 minus cosine of theta. Oops, not squared. There we go. So this is an alternate way of expressing sine squared, just by factoring using difference of squares. Similarly, we could have done the same thing for rearranging, right? If we solved for cosine squared of theta would equal 1 minus sine squared of theta. So there's alternate ways of looking at that one. Let's look at this next one here. 1 plus tan squared equals secant squared. Well, this is not a difference. This is a sum of squares, and that cannot be factored. But in order to make it a difference, we could do a couple things. I'm going to subtract this 1 here from both sides. So if we do that, this gets rewritten. We subtracted the 1 from the left-hand side, so we're just left with tan squared equals secant squared minus 1. So I just rewrote it differently, right? Well, this is a difference of squares. How can that be factored? It can be factored into secant squared. Oh, I keep doing that. It can be factored into secant theta plus 1, secant theta minus 1. And that's just an alternate way of writing secant squared theta minus 1 using the difference of squares. All right, I want you to try this last one here on your own. So if we rearrange this equation, or this identity rather, we would have cotangent squared equals cosecant squared minus 1, just an alternate way to write it. Go ahead and factor this side. Pause the video, factor it, and then play to see how you did. Okay, we have cosecant squared theta minus 1 factoring into cosecant theta plus 1, cosecant theta minus 1. So we're going to use the idea of difference of squares quite often with trig functions in order to simplify them. Okay, one way that we can simplify, well, another way besides factoring using difference of squares, is by just getting everything down to the basics. I remember yesterday I told you that our basic two trig functions, kind of the building blocks, are sine and cosine. And if you're ever asked to simplify, that is really one way to go about it. So in this example here, and I'm just using one from your book, page 315, example 4, it's asking us to simplify the following trigonometric expression here. Now, in order to rewrite this in terms of sine and cosine, we have to remember what each one is, which is why I put this over here. So let's decide the best way to write each thing. Cosecant is the reciprocal of sine. So we can rewrite cosecant. So what I'm going to do is just move this down here. So cosecant is 1 over sine. And then secant, as we know, is the reciprocal of cosine. All right, so we have that minus cotangent. Well, what is cotangent? All right, cotangent is cosine over sine. So we can rewrite using that. Okay, now that we have that, let's multiply this first fraction here. Remember, when we're multiplying fractions, we multiply just straight across the top, straight across the bottom. We're not cross-multiplying and multiplying in an x. That's because we have a multiplication symbol here, not an equal sign. So when we multiply, this becomes 1 over sine theta cosine theta minus cosine theta over sine theta. Okay, now what to do from here? So we have two fractions and they need to be subtracted. When you have any fractions that need to be added or subtracted, you need you got it, common denominator. So let's think about what our common denominator needs to be. Our common denominator needs to be sine cosine. This one's just missing the times cosine. So what we're going to do is a totally legal math move. And since this denominator needs cosine, we're going to multiply by cosine theta. And then since we multiplied the denominator of that fraction, we have to multiply the numerator. Now we can do that because we're multiplying by cosine over cosine, which is just a 1. So that's fine. All right, let's rewrite what we have. We have 1 over, this fraction didn't change. And then this fraction did, right? Our numerator is cosine times cosine, or cosine squared. And our denominator is sine cosine. Okay, now we have a common denominator. Very cool. So since we have that common denominator, we can rewrite as one single fraction with that denominator. And the numerator is 1 minus cosine squared. Awesome. So again, all we did, right, if we were to do like 5/8 minus 4/8, right, we'd have 1/8. That's essentially all we did. You know, our denominator doesn't change, right? It's still an eighth or whatever. That's just an example I made up. And we subtracted our numerators. Okay, now what do you notice? I see a 1 minus cosine squared. I know this is all new to you guys, and so it might be harder to see this just because you haven't practiced it as much. But in general, if you see a trig function squared with like a plus or minus 1, chances are it's one of these Pythagorean identities. Now, can we rearrange to figure out what 1 minus cosine squared equals? Yes. We're obviously going to use the top one because it's cosine squared. So let me blow this up a little bit. And we can see, oops, this guy right here can just be rewritten, right? So it can be rewritten, and I'm not gonna have enough room, there we go. We can rewrite to get sine squared equals 1 minus cosine squared, right? Because all I did was subtract cosine squared from both sides. So what does that mean? It means that 1 minus cosine squared can be written as sine squared because that's what it equals. So that's what we're going to do. So going back to here, I'm going to replace the numerator with sine squared. Then we have our denominator, which is sine theta cosine theta. I don't have any more adding or subtracting, right? My numerator is one term, my denominator is one term, right? All attached through multiplication. That means that canceling is a legal mathematical move. We have a sine squared on top and we have a sine on the bottom. That means that one sine on top and bottom can cancel. So that makes it just a regular sine on top, and this sine goes away. So we're left with sine over cosine. And what is sine over cosine? Tangent. That's our answer, folks. All that work for a lousy tangent, right? But hey, it's a good time, so, you know, we did it. Awesome. Let's do another one. Okay, here is the you try example. So go ahead and write this down, pause the video, and then play to check. Okay, please check your work. The answer is cosine x. I'm going to walk through it. If you don't need this, then go a little bit ahead of the video, that's fine. Secant is 1 over cosine. Tan is sine over cosine times sine. How do you rewrite sine? It's already in terms of sine. You can rewrite it as just sine over 1. That's fine. Same goes for cosine. All right, so when we're simplifying these two fractions multiplied together, we end up getting sine squared for our numerator and cosine for our denominator. We actually end up having a common denominator, so no need to, get one. We already have one. So we can write it as a single fraction. 1 minus sine squared is, you guessed it, cosine squared, using this top Pythagorean theorem over here. We have cosine squared over cosine, so one of the cosines can cancel, leaving with a single cosine in the numerator and nothing left in the denominator but a 1. No need to write that, and that's our answer. Okay, let's move on to some fraction examples. I guess we've already kind of been working with fractions, but here, we have two fractions that we're subtracting, and we need to get a common denominator. We already kind of have some experience with that common denominator, but let's think about what our common denominator should be here. Our common denominator needs to include 1 minus sine x, and it needs to include cosine x. So our common denominator should be, where should I write this? I'll write it over here for now, but I'll probably end up erasing it to get more room. Our common denominator should be 1 minus sine x. That's like a single thing. It's one of the factors. And then cosine x. That's what it's going to be. That's what both our denominators need to look like. So since both our denominators need to look like that, what I'm going to do is rewrite this problem so we have a little bit more room to work. So we'll have sine x cosine x over 1 minus sine x. And I'm going to put that in parentheses for now. Minus 1 plus sine x. And that's an expression as more than one term. I'm going to put it in parentheses. Over cosine x. All right, we need both of our denominators to be this. So our first denominator has the 1 minus sine x, but it's missing the cosine x. So we need to multiply by that. So we're going to multiply both the denominator and, you guessed it, the numerator by cosine x. Great. Then Our second fraction, the denominator is missing this piece. It only has the cosine piece. So we need to multiply both the top and bottom by 1 minus sine x. Okay, cleanup time. So this first fraction here has this denominator now. And the numerator is sine times cosine, which is sine and then cosine squared. Okay, our second one has again that denominator, and I'm just going to write it in the same order so they look similar. Okay, our numerator, let's think about what our numerator means. We talked about this earlier today. We have 1 plus sine x, 1 minus sine x. That is a broken down difference of squares. If we were to multiply it out, we'd have 1 minus sine x plus sine x. They cancel. Minus sine x squared. That is this. 1 minus sine squared x. Awesome. So we recognize now, that can't we rewrite this as something? 1 minus sine x is cosine squared. Sorry, 1 minus sine squared x is cosine squared, using that Pythagorean theorem. So once again, let's rewrite. So we have sine x cosine squared x. And then this is just going to get rewritten as cosine squared. And in the same step, I'm just going to write it as a single fraction. So minus cosine squared x. All over their common denominator. 1 minus sine x times cosine x. Great. Again, I went from here and replaced it with this. That's what I just did. Okay. Let's make a little bit of room here. Now, what can we do from here? We have it as a single fraction. Well, if you look at our numerator, we can factor something out of both of those terms. What do they have in common? They have a cosine squared in common. So we can take the cosine squared and factor it out. And we are left with sine here, and then a minus 1 over here. I know this example's a lot, but you guys got this. All right. What can cancel now? These look like they can almost cancel. They almost can. In fact, when you have stuff that's flipped around like this, instead of canceling to just a 1, they actually cancel to a negative 1. If you're interested in why, I can show you here off to the side at the end. But since this term and this term are just like flipped around basically, they cancel to a negative 1. So this and this cancel to a negative 1 over 1. And then we can see that the cosines, one of them can cancel, just like we've been doing. So what we're left with is a cosine in the numerator and a negative 1, so negative cosine, over nothing in the denominator. So our answer is negative cosine. Here's why that works to cancel to be negative 1. I'll show you over here. We have this, sine of x minus 1 over 1 minus sine of x. What I'm going to do to make these the exact same is I'm going to factor out a negative 1 from the numerator. If I factor out a negative 1 from the numerator, I'm left with negative sine x plus 1 over 1 minus sine of x. These are now the exact same. They have a positive 1 in each and a minus sign of x, so they are the same thing, so they cancel. And you're left with just a negative 1. So it's just a little quick fun thing. So anyway, that was a crazy example, but thanks for taking the ride with me. That was a good time. Our answer is negative cosine. And just FYI, the book shows this example slightly differently than I did, but there's just different algebraic ways to look at stuff. This is just an alternate way. So if you want to reference the book example, they do a nice job also, and it just looks slightly different, but you end up with the same answer. Very cool. Here is another example of simplifying with fractions. So we can see that our two denominators are different, and so we need the common denominator. Our common denominator here is going to include both, so it has to be 1 minus secant theta and 1 plus secant theta. That's what we want our common denominator to be. So we have only the 1 minus secant theta here, so we need to multiply both top and bottom by 1 plus secant theta. And then on this side, we only have the 1 plus secant theta, so we need to multiply top and bottom by 1 minus secant theta. Okay. Now, what are we left with? Well, we are left with, if we look at this numerator, we're multiplying 1 plus secant theta by secant theta. So we're going to distribute the secant theta through. So when we distribute that secant theta through, we're left with secant theta plus secant squared theta. When we distribute the secant theta through here, we're left with secant theta minus secant squared theta. Oops. Okay, then let's look at our denominators. And our denominators, again, are when we multiply them together, right? This is a broken down difference of squares here. So when we multiply it through, it's, 1 minus secant squared theta. So that's our denominator. Okay, now we're going to combine this into one fraction since our denominators are the same. And when we do that, when you have a subtraction sign, you need to be careful that you're subtracting both pieces. You're essentially distributing a minus sign through. So if it helps, put this in parentheses. So, and I don't know what I wrote over there. Let's fix that. This should be secant squared. Okay. So when we are distributing the minus sign, right, this first part, it's not going to change. We'll just bring it down. So it's secant theta plus secant squared theta. Then we'll distribute the minus sign through. So it's minus secant plus secant squared. All right, let's simplify that a bit. So we have a secant minus a secant, and then we have a secant squared plus another secant squared. So that gives us 2 secant squareds. And then our denominator, let's think about how we can rewrite that. Again, we see a 1 and then something squared. So that means that it's probably a Pythagorean identity over here. It's probably this middle one, right? 1 minus secant squared. Let's see how we can perhaps rewrite that. All right, this one's going to be a little bit more challenging to rewrite, so let's work on that. So I'm going to take this identity and just mess with it a little bit down here. All right, we have 1 plus tan squared equals secant squared. And remember, we're trying to get this so we can rewrite it. Well, if I subtract 1 from both sides here, I have like the backwards version of what I want. I want to replace 1 minus secant squared, but I end up having secant squared minus 1. So essentially I want the 1 to be the positive thing and the secant squared to be the negative thing. And I have it backwards. So how do I alleviate that? How do I turn it to the opposite? Well, I multiply everything through by negative 1, both sides through. So I'll have negative tangent squared equals negative secant squared plus 1. And this is really 1 minus secant squared if you just rearrange it, right? Because the secant squared is the negative piece. And so I see that, hey, okay, what I had was almost what I wanted. It was just flipped around. So I can replace 1 minus secant squared here with negative tan squared. Cool. All right, we're getting there. So let's try to simplify, let's try to simplify this as much as we can. So what do we have? Well, I can rewrite secant as something, and I can rewrite tangent as something here, secant squared and tangent squared. So let's rewrite those in terms of sine and cosine to clean some stuff up. So secant squared, so 2, and then what is secant? Secant is 1 over cosine, so I can replace this with 1 over cosine squared. And so I can really just rewrite that as 2 over cosine squared. I don't need all these parentheses here. The 2 can just go in the numerator. Cool. Over, it's a complex fraction, right? Okay, how can we rewrite tangent squared? Well, we can rewrite tangent as sine over cosine, so we can rewrite this as negative sine squared over cosine squared. All right, we're almost there. What can cancel? These can. Cool. So we're left with 2 over negative sine squared theta. And then finally, let's rewrite it so we don't have something in a denominator. Anything over sine, right? The reciprocal of sine is cosecant. So we basically have a negative reciprocal of sine, so negative cosecant squared, and then we just have a 2 out in front. So our final answer is negative 2 cosecant squared of theta. Yes, these seem like a lot, I know. We're not going to have a new lesson tomorrow, so tomorrow will be more opportunity for you to practice. On the next slide, I have one for you to try, so another example problem. Okay, go ahead and write this one down and work through it. Pause the video and then you can play to see how you did. Okay, our final answer for this one is 2 secant x. I'm going to work through it. If you need to forward ahead, feel free. So the green is what we started with. This is our common denominator. So we multiplied through appropriately. When multiplying through, this gave us cosine squared. On this side, I multiplied through and got 1 plus sine x plus sine squared x. Combining like terms, this is 2 sine x, that's where I got this. I brought down the sine squared, brought down the 1, brought down the cosine squared. So we had these 4 terms. And then our common denominator. Then, this was the tricky part, but the granddaddy of all the trig identities, cosine squared plus sine squared, is 1. So we can rewrite the cosine squared plus the sine squared as 1. We still had the plus 1, the plus 2 sine x over that denominator. Combining like terms, this gave us 2 plus 2 sine x, still the same denominator. You could factor out a 2. When you factor that 2 out, you're left with 1 plus sine x, which cancels with the 1 plus sine x in the denominator because, again, it's in parentheses, it's a factor. And then we're left with 2 over cosine, and the reciprocal of cosine is secant, so 2 secant. Okay, best slide. These are your problems for today. I gave hints for each one. Tomorrow, you will not have a new video to watch or anything. You will just have like virtual board work day, so just a practice day. And remember, you can ask me questions on Zoom from 9 to 10 a.m. I put my Zoom ID on Blackboard and in the email that I sent out to you guys this morning. So if you have questions or need to make any corrections at any time to your assignments, that's where you can do it.